Hi everyone, welcome to the Earth Science Regents Review podcast series created by Helmix Middle School Earth Science Department. Today we're going to focus our attention on porosity, permeability, and capillarity. Now whenever you talk about any one of these three factors, you're dealing with soils. Now remember, soils are made of weathered rock remains and biological activity, or organic remains of dead plants and animals. Now soils, depending on the characteristics of size, shape, packing, sorting, and a couple of other factors, are going to influence how easy it is for water to work its way into the soils. Now we have a lot we have to talk about today, so we're going to have to go through this kind of quickly. When you look at soils underneath the microscope, you'll see that there's a variety of sizes, shapes, even colors, packing, organization. A lot of factors are going to influence how easy it is for water to work its way into the soil. So when you talk about groundwater, groundwater gets there by two major factors: the porosity of the soil and the permeability of the soil. These are ultimately going to have a major influence on how the infiltration is going to take place within a certain sample that you're looking at. Let's focus on porosity first. This is essentially the empty space found in between the soil sample. So when you look at soil particles, based upon their size, their shape, their packing, their sorting, the little spaces interconnect themselves to make a little bit of an avenue, or almost like a roadway, for the water to work its way down into the zone of saturation. Now we're going to talk about the factors that are going to ultimately influence how easy or how difficult it is for the water to get into the zone of saturation through these soil samples. And the first factor is the shape. Round fragments tend to have a high porosity. Flat fragments tend to have a very low porosity. Well, if you take a look at your flat fragments, they get packed really close together. Those flat edges don't allow for a big space in between them, and the water is very, very, very difficult to get through those really teeny tiny spaces. You compare that with rounded fragments, you have much bigger openings for that water to get through. So you physically have bigger pore spaces here, which allows for easier infiltration or a higher permeability. The second factor is what we call the sorting. Well sorted tends to have a high porosity. Poorly sorted tends to have a low porosity. And it's all based upon the size and the shape of the fragments. If you have uniform sizes and shapes, you'll have a well-sorted sample. If you have a mixture of particles, those mixture particles dramatically lower the porosity. You tend to have the lowest porosity and the lowest permeability with that type of sample. Now let's take a look. Here's a sorted sample, all relatively the same size and shape. Here's an unsorted sample. You see that the smaller fragments really clog up the bigger pore spaces, dramatically dropping porosity in this case. The third factor is what we call the packing. You can either have loosely packed, which the fragments are really far apart, or you can have tightly packed, where those fragments are really close together. Now, your loose packing tends to have a higher porosity. Your tightly packed tends to have a much lower porosity. Your pore spaces just are not physically as big anymore, so you're dealing with a much lower porosity and much lower permeability on the right with the tightly packed. You compare that with the loosely packed, which allows water to flow through much more easily, much higher porosity on the left. Now those are the three factors that are going to influence your samples. Every once in a while you'll get questions on the regions that pertain to comparing 3, 4, 5 different samples of soils that have same volumes, same shapes, and same packing. Now when you compare these samples, the porosities are all going to be the same, and let me explain why that is. You can have a sample of small fragments, a sample of medium fragments, and a sample of large fragments. You notice that they're all the same volume, they're all the same shape, and they're all organized in the same way. You'd say each sample is well sorted. Well, here's how your samples are all going to have the same porosities. The sample on the left has smaller pore spaces, but there's a lot of them. The sample on the right has large pore spaces, but there's much less of them. What happens is, because your large pore spaces, there's less of them. On the left, you have smaller pore spaces, but the more of them. In the middle, you kind of have the average of both. They're all going to equal each other out. And you could actually take these samples and fill them up with water. They'd have identical volumes of water because they have identical porosities. That leads me to permeability now. And this is the ability for water to pass through. Again, this is actually dealing with the actual physical size of the pore space. The bigger the pore space, the easier it is for water to pass through. So there are some factors that are going to influence permeability. The great thing about this, the characteristics that influence porosity, the same characteristics influence permeability as well. The shape of the particles, round versus flat, is going to affect your permeability. Your rounder fragments compared to your angled fragments, you can see the rounded fragments have a much higher permeability because they have bigger pore spaces. The angled fragments have much lower pore space, much lower permeability. Next up is going to be the sorting. Well sorted gives you a high permeability, poorly sorted gives you a low permeability, and that even leads us into our mixture as well. Mixture is going to have the lowest permeabilities of all. Again, you want to take note of a sorted, high pore space, high permeability. Unsorted has a low porosity or low pore space and a much lower permeability. So very important to understand that porosity and permeability are going to work together with each other. And the last factor that affects permeability is going to be the packing. Loosely packed gives you a high permeability. Tightly packed gives you a low permeability. Again, it's all based upon the spacing in between the fragments. High porosity, high permeability. Low porosity, low permeability. So very important for you to be able to identify the differences in regards to porosity and permeability and even some of the similarities as well. Next up is capillary action. And this is basically the upward movement of water through the soil. And what happens here is plants are going to use this water in order to survive. They're going to draw that water upward through the soil. And that's all based upon a process called capillary action or capillarity. Now, a lot of times, this water is going to be drawn upward through the soil because water has very sticky properties. It loves to stick to soil, specifically soil with what we call a high surface area. And when we talk about the factors that are going to influence capillarity, it's all about particle size. Smaller the particle, the more attraction the water is going to have to it. Because small particles in big quantity have a huge surface area. More surface area, the more surface areas for water to cling onto, the more attraction it's going to have to it. Okay, so small particles in big quantity have a very, very big surface area. So you can see here as this spherical object, okay, changes into a square or a cube, that cube gets broken up into pieces, and then that secondary cube gets broken up into even a number of pieces. So you see the cube in the bottom right with all the little pieces, that has a much higher surface area because of the number of pieces. Collectively, there's a lot more surface for water to cling onto in the bottom right compared to the upper right. So that's what we talk about in regards to surface area. Now you can see that you have small beads, medium beads, and large beads. Again, similar to what we just talked about with some of our porosities. Now, you have the greatest capillarity with small beads because you have the greatest surface area. On the right-hand side, you have the large beads. That's going to be the lowest capillarity because you have the least amount of surface area. Look at the quantity of beads. You have a lot more beads in the small beaker compared to the beaker containing the large beads. So when you have small particles in big quantity, that's what we consider a big surface area. So particle size decreases, your capillarity is going to increase. So please make sure that you take note of all the groundwater characteristics and some of the relationships. I made a podcast with those. There's about 25 characteristics that you need to know just regarding groundwater relationships. So that's it for now. Hopefully you got down a little bit with porosity and permeability, and we'll talk to you soon.